get up to here, we're almost there. We're going to hit natural log on both sides. Very good. So all that work and 4 steps. So again, I can't stress enough. This shows that it does work with k plus 1. So QED, therefore. Vector for 3, 0. And let's plug in our input. 3, 1 is 3, and that's the same thing as 6C3 to the 2, which is 3, and then finally C33 is 1. So there's our coefficients, and we'll say that this is x cubed, 4 to the 0 is 1, so this becomes 3x squared, 4 to the 1, and then times that by 4 times 3, which is 12, plus here we get 3 times 16. 3 times 16 is 48. So we get 48x. And then finally our last one, C3 is 1, and 4 cubed is 64. So there is using our formula for the binomial expansion of to the third. Okay, so a simple one, not too bad. Okay, so that is a good place to stop right now, and let's take a look at everything we've done in this lesson. And the big idea was the binomial theorem. So we talked about the binomial theorem. And to get the binomial theorem, we saw our C, Cn, R. Okay, we used our C's, and that was it. So we used the binomial theorem. Remember the coefficients. This gave us the coefficients of our binomial expansion. Okay, we used the C formula, and again, our C formula for C and R is going to give us n factorial over n minus r factorial times r factorial. Okay, so there is our, and remember, you say, why do we use the C formula? We use the C formula because that turns out to be the coefficients for our binomial expansion. All right, so that is a good place to give you guys some practice with this. This is section 9.5. 9.5, and numbers, let's see what numbers we want to give you guys. Numbers 4, 8, 10, 28, and 48. So that's section 9.5, covering the binomial theorem and our C's. Okay, and that is the end of our lesson. I hope you had a good time. I did. Can't wait to see you guys again. Goodbye. Welcome, class. Welcome back. We're going to go over section 9.5, the homework from section 9.5, and we were dealing with the binomial theorem. So let's take a look at section 9.5, and the first question, question number 4, asks us to find C20, C20. 20 choose 20. 20 choose 20, we should realize, is just 1. There's only one way for 20 people to choose 20 things. That's 1. Very good. Next number was number 8. Number 8. And we're given C 10 choose 4. 10 choose 4. We put it into the formula, and we know it's going to be 10 factorial over 10 minus 10 minus 4 factorial times 4 factorial. Okay? So if we work that all out into the formula, we plug that all out, and what do we get? We get 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 10 minus 4 is 6 factorial. So that's going to give us 6 times 5 times 4 times 3 times 2 times 1. Okay? And then 4 factorial is just going to give us 4 times 3 times 2 times 1. Okay? Now, cross that out, cross that out. Of course, if you have a calculator, it goes much quicker. But we're showing you how to do it out. I know 4 times 2 is 8. There goes 8. 3 goes into 3, goes into 9 3 times. So what am I left with is 10 times 3 times 7, which is 30 times 7, or 210. Okay? Not too bad. The next one was number 10. Now 10, the reason I gave you this is because I wanted you to realize that 10 choose 6 is also the same thing as 10 choose 4. And we already did that work, so we already know that is 210. Okay? Very good. So there's our C's. And of course, the next question is going to ask us about the binomial theorem. And that's question number 28. 28. So here we have 28. And it says that 2x minus y raised to the 5th. Okay? So we did the binomial theorem, so we're going to use our binomial theorem to answer this instead of multiplying it out 4 times. So we know that the first entry is going to be 5c0, 2x to the 5th, y to the 0. Okay? And our next one's going to go 5c1, 5c1, and 2x to the 4th, y to the 1st, plus 5c2, 2x to the 3rd, y squared. Get a nicer 3 there. Okay, so we keep expanding. Then we have 5c3, 2x squared, y to the 3rd, plus 5c4, 2x to the 2x to the 1st, y to the 4th, and then finally 5c5, 2x to the 0, y to the 5th. Okay, so of course we want that all worked out for us. This is 1, 2 to the 5th is 32. So that's 1 times 32 is 32. x5, y to the 0 is 1, plus, this is 5, 2 to the 16 is 5, is 80. 80, x4, y1, plus, we know 5 to the 2 is 10, and this is 8. 2 to the 3rd is 8. 8 times 10 is 80. x3, y2, plus, we're here, 5c3 is the same as 5c2, so that's a 10. 2 to the 4th, 2 to the 2nd is 4. 4 times 10 is 40. 40 x squared, y cubed, plus, now we're here, 5c4 is the same thing as 5c1, which is 5. 2 to the 1 is 2. 2 times 5 is 10. 10x, y4. And our final entry, 5c5 is 1. This is 1, y to the 5th. So there is our binomial expansion. Using binomial expansion, here is our final answer for number 28. Very good, all right? And then our last question was number 48. Similar question. But they're asking us in 48, they say here is our binomial raised to the 12th. What will a z6 be? So that tells us that we're looking for the sixth entry into this. So we say that a z6 is going to give us the same as 12c6. Okay, and 12c6 is going to be 12 factorial over 6 factorial times 6 factorial, which if we work out becomes 924. Okay, so there it is, 924, and that is what a is equal to, equals a. Okay, and this you can work out in a calculator. We've worked out a bunch of these problems before, so it's 12 factorial over 6 factorial times 6 factorial, which turns out to be 924, which is A. All right, very good. That comes to the end of our lessons right there. That was a great time being your pre-calculus guide. Hope you enjoyed it. I sure did. Hope to see you guys again someday. Good luck out there. Bye-bye.